Now in this video lecture for class 12, we are going to introduce capacitors. Actually, in daily life, we have seen so many devices that runs on electricity. Capacitors. Okay? We have television, we have computers, we have electric fans, so many other devices are there in daily life which we use, and that needs a large amount of current at a time. When we switch on it, it takes a large amount of current to start, but the current which is there in the circuit, that is quite less than that the value of the current is needed by that device. So how that devices starts? This is a big question. Now we have a device that is known as capacitors. So capacitors are there generally in all the electrical devices, and it stores a large amount of electric energy, and it supplies the electric energy when it is needed instantly. And for then running the device, suppose a fan is there, so that capacitor stores the electrical energy and it provides at the time of instant when we switch on. Then when the fan runs or when it is in motion, then a less amount of current is needed, and that supply current is sufficient to maintain its motion. Okay, so we can define as capacitors are the device that stores electrical energy. Or we can say electric charge, but the best is to say it stores electrical energy and supplies when it is needed. Now we have one more term here, that is capacitance. Capacitance. So the device is known as capacitor, and its ability of storing the electrical energy is known as capacitance. So we can define the ability or property of a capacitor to store electrical energy is known as capacitance. Okay, so capacitor is the device and its energy storing capacity is known as capacitance. Now in last lecture we have just studied about the potential. We have the formula for potential: V is equal to K Q upon R. Okay, so from this formula we have a concept that we can write Q is directly proportional to V. That means Q increases with the potential, or when potential increases, Q also increases. When potential decreases, Q also decreases. So this is an inequality sign, and then we have to put here a constant, so we can write Q is equal to. Then we have to introduce a constant here, and that constant is known as C, V, and this C is known as capacitance. So this C is known as capacitance, or we can write C is equal to Q divided by V. In this manner, we can define the capacitance. As far as its unit is concerned, we can write its unit. Unit of Q is Coulomb and V is volt. So Coulomb per volt is its unit, or that can be written as Farad. Farad. So these are the units of this. Now the question arises whether C depends on Q or not, or whether C depends on V or not. So the question is C does not depend on Q and C does not depend on V, but C depends on the ratio of Q upon V. It depends on Q upon V ratio, not on Q and V. Now look how. Suppose we have an isolated sphere. Suppose I am taking an isolated sphere which is given a charge capital Q. This is an isolated sphere and it has charge plus Q and its radius is R. Okay, so we can write its potential as V is equal to 1 upon 4 pi epsilon naught Q upon R. Okay, now with the help of this formula we can write Q upon V. So Q upon V that is equal to 4 pi epsilon naught R. Okay, and this Q upon V we have just studied, it is nothing but capacitance. So this is the formula for capacitance of an isolated sphere. Okay, now here if we look at the things on right hand side, 4 pi epsilon and the radius, these all are constant. So for a given conductor, Q upon V is constant. So C depends on the constant, this ratio Q upon V. If V increases, there may be change in Q, or if there is a change in Q, V changes, but the ratio always remains constant, and that C depends on this ratio. Now one more thing is there from here. If we consider this sphere as Earth, so we know that the radius of Earth is 6400 kilometer, or we can write 6400 into 10 to power 3 meter. Okay. Now if we want to calculate the capacitance of this one, so with the help of this formula we can write C is equal to, this is reciprocal of 1 upon 4 by epsilon naught. So its value will be 9 into 10 power 9 in denominator, and then R is there in numerator, so that is 6400 into 10 to the power 3. Okay, so when we solve it, we will get the value 711 into 10 power minus 6 farad. Okay, and 10 to the power minus 6 we can write micro. So this one is 711 microfarad. That means we know that Earth is such a big sphere, and that much big sphere has the capacitance of only 711 microfarad. So we can guess how big a farad is. So we cannot use farad because it is very big unit. If we take Earth, then its capacitance will be only 711 microfarad. So farad is very big unit. That's why we generally use the capacitance. To measure the capacitance, we use microfarad, picofarad, and these type of other units. So this is all about the concept of capacitors, and we have derived the formula for the capacitance of an isolated sphere. Now as far as its principle is concerned, we are going to discuss the principle of a capacitance. For that, I am taking parallel plate capacitor. Capacitors are of so many shapes and sizes, but in your syllabus only parallel plate capacitor is given. So I am taking two plates. Okay, actually this signal is visible to you, but this is a type of sheet. This type of sheet is this. This is the front view and this is the side view. Okay, this type of sheet is this. This one is one sheet and this one is another sheet. And since both the sheets are parallel, so we term it as parallel plate capacitor. Now, to one plate, we just connect it to the positive terminal of battery. Okay. Since it is connected with the positive terminal, so positive charges will be here on both the sides. Okay. Now, what will happen? It is neutral. So, because of the induction effect of this one, positive attracts the negative and negative will appear on this plate, and then positive will appear, or we can say it is get repelled by these charges and will be shown on the next side of the plate. Next we will connect this to earth. This one is earthing. Okay, so under this effect, these positive charges gets lead to the earth. So this is the construction of parallel plate capacitor. Okay, clear? And this area of each plate, area of each plate, we take it as A, and this separation between the two plates I am taking small d, and its capacitance, or we can say first we are taking its potential. So P V is equal to K Q upon R is its potential. Okay, so this is the construction of parallel plate capacitor. Now the question arises, if we have to increase or decrease the capacitance, so how we can increase or decrease the capacitance of a conductor? Now suppose we have an isolated sphere, positively charged sphere, which is given positive charge plus Q. This one plus, okay, and its potential is V is equal to K Q upon R. Is it okay? And we wish to change its potential without changing anything in it. So this is our original case. Now what we will do, we just, this one is our case 1 I am taking. This is our sphere which is positively charged. Okay. Now I place another conductor near it, and this one is neutral. This one is neutral conductor near plate. Okay. So what will happen? Due to induction, negative charges will appear on this side and positive will appear on this side. Okay. Now consider the distance between this positive and this negative as R1, and this positive and this negative as R2. Is it okay? So the original potential of this one is this. Now I am taking its potential as V1 and its potential as V2. So V1 is equal to K Q upon this R1. Okay, and V2 is K minus Q. Sorry, here This one is minus Q and here it is plus Q. So K Q upon R2. Okay, so the net potential will be V plus V1 plus V2. Okay, and V, the value of V is K Q upon R, and V1 is minus K Q upon R1 plus K Q upon R2. Okay, now which potential V1 or V2 is greater? Now we know that potential is inversely proportional to distance. So if distance is less, potential will be more. So this distance is less, so this negative potential will be more. This negative potential will be more as compared to this one. So when we solve it, these two, its value will be negative, something negative potential. That means we have to subtract certain potential from this value. And finally we get that the potential gets decreased. So if potential will be decreased, then capacitance will be also decreased. Okay. Now further, if again we have to decrease the potential, then what will we do? Look here. This one is case 2. Case 2. This one is isolated sphere. Now in this case, we put a negatively charged sphere. This one is negatively charged sphere. This distance is R1. This distance is R2. Its potential is V1 and its potential is V2. Now V1 is equal to minus K Q upon R1 and V2 is equal to minus K Q upon R2. Now these two potentials here are negative. So their sum will be negative value, but large negative value. So when we subtract, we get the net potential by this method, V plus V1 plus V2. And since these two are negative, so we have to subtract a large value as compared to this one from this, in this case. So the potential further decreases. So by this way, we can reduce the potential and we can increase the capacitance of a conductor. So this is the general principle of conductor, how we can change the capacitor.